Okay, so we're looking today at 3D vectors. So our learning intention is to gain knowledge in how to perform mathematical processes with vectors in 3 dimensions. We'll be successful if we can calculate the magnitude of a vector in 3D, calculate the unit vector, and add, subtract, and scale multiplications for vectors in 3 dimensions. So in 3 dimensions, I just got these from different internet sources. We have 3 planes, right? We have the x axis, or the I component, right, coming out at 45 degrees. The y is the j component, that's going to go horizontal, and the z is the k component. Okay, so if you think we're going to go 2, like the point 235 goes 2 in the I component, 3 in the y component, in the j component, and then 5 up into the z component. And you're trying to think that it's done in using 3D boxes. So it's going from the origin, going to this point here in the column. Okay. Now to find the magnitude, all we're going to do is very similar. We're going to now find the square root of each side squared, and then obviously the unit vector is going to be taking out that scalar magnitude. Let's do some examples. We want to find the magnitude of this vector, which is 2 in the I component, negative 2 in the I component, 2 root 3 in the j component, and 3 in the k component. So the magnitude of this vector is negative 2 squared plus 2 root 3 squared plus 3 squared. So that's going to be 4 plus 12 plus 9, so 21, so 25. So it's going to be 5 units. Okay, that's using the formula that R is x squared plus y squared plus z squared. Okay, we want to find the unit vector of u. Okay, so the first thing we need to do is we need to find what u is, the magnitude of u. So that's 1 squared plus 3 squared plus 2 squared. So 1 plus 9 plus 4, which is root 14. Okay, so the unit vector is going to be, I'll use the notation. So the unit vector is going to be 1 over 14th of this vector. Yeah, which we could write it as I plus 3 in the j component plus 2 in the k component. Okay, that's using the formula that unit vector is the vector divided by the magnitude. Okay. Now we want to write down the vector AB joining A and B, and we want to determine its magnitude. Okay, so I'm going to start at A and go to B. Now to find that vector, all I do is have B as my first coordinate, and I subtract it from my A coordinate. Yep. To find the different, how many units it's changing. Okay, so that's vector AB. Start at A going to B. Now if I want to find that magnitude, square each term. So works out to be 5 root 5 units. Okay. Alright, so now I want to add and subtract some vectors. I've got u being that and v being this. Okay. I'm going to write them in column form. So u is 1, 2, 3. And v is 4, 5, 6. So I'm going to add vectors. All I'm going to do is add the I components together. So 1 plus 4 is 5. Add the j components. 2 plus 5 is 7. And add the k components. So I get 5i, 7j plus 9k. Similarly, if we're going to subtract, we get negative 3, negative 3, negative 3. So we get negative 3i minus 3j minus 3k. Now, if we want a scalar, so that means 2 lots of u plus 3 lots of v. That's the same as writing it as multiplying each term by 2 and multiplying each term by 3 and then adding each component. We get so we get 14i plus 19j plus 24k. Okay. And that's it. Good luck.